Hi, and welcome back to another Siemens S7-1200 and FactoryI tutorial. In this video, we will be carrying out some setup procedures using the TIA portal to allow us to structure the programming code for the removal of pallets from the rack. Now, unfortunately, it isn't the most exciting content we've produced so far, although I would say it is essential background information that will help us understand why we are coding things in a certain way as we move forward. So stay tuned. Okay, this is where we were at the end of the part 11 video, where the pallets were placed into a position in the rack determined by the number in a destination word and incremented by 1 each time a pallet was placed until the rack was full. We had no way of removing a pallet, and even if we could, we had no way of replacing it with another pallet, as the code was quite basic, although I think it was a good introduction to SCL programming. This time we will be changing the code considerably, so that we can not only remove pallets from anywhere in the rack, but in addition, once a pallet has been removed, we will replace it with the next pallet coming through on the conveyor. To achieve this, we will need a method of checking what is in the rack at any given time and keeping a running tally when the rack contents change, so we know where the next pallet can be placed. If you take a look at the previous part 12 video, it should help explain where rack content information is stored. However, before we start coding, we need to carry out some housekeeping and modifications to where we were in the part 11 video. So, what will we be covering in this video? Firstly, we'll rename a couple of tags that may have caused a little confusion in the part 9, 10 and 11 videos. Then we'll create another tag table and enter some of the tags we will be using in the following videos. We will then set up a new program structure for the code to be entered using additional functions. Then we'll modify the existing ladder and SCL output logic to make use of the new structure. We'll then modify the SCL sequence numbering system, which steps through the load pallet sequence procedure. And lastly, we'll modify a few SCL if not variable statements and replace them with if variable equal to false statements, as the not can also be a bit confusing. After that, we should be ready to start coding. Now, it's worth noting I have named the PLC program file Part 12 video, when really I should have named it Part 13 video, which was a typo. But I hope this doesn't confuse things when I start referring to the previous video, as the work we will be doing is the same whatever the file name is. Also, some of you may feel the content to be quite mundane, but unless you are an experienced programmer, I would recommend following what we are about to cover, as it will help explain the ideas behind the code we'll be entering. Right, let's start. We'll rename the two tags that may have caused some confusion. Let's have a look at the code in function 1 to view the tags. And straight away you see the tag word to shift, which is updated at the end of each step in the code after the current step in the process of placing a pallet in the rack is complete. If you watch the part 9 video for a few minutes from 15 minutes and 20 seconds onwards, it explains why we used this tag name. However, it may have been confusing, so let's rename it to something that makes more sense. And later in the video, we will also change the way its value is incremented. So let's rename this tag to place pallet sequence number. I'll just do that in tag table 2 now. Let's click in the field and enter the abbreviation place pal seek number and enter. Now the other tag name I would like to change is Eye Reflective Sensor 5, as this really doesn't mean anything. This is where the particular input is in the FactoryIO setup, right at the end of the last conveyor to detect when a pallet is present. So I'll just rename the tag to Eye Stacker Crane Entry and enter. Now let's create a new tag table and enter the tags. However, instead of entering all the tags manually, as and when we need them, we'll import them from a saved Excel file that I exported out from the completed removal video. Let's select the path, and the file is called revised load rack. Let's OK it and wait for the tags to be imported. Import completed successfully. I'll just click on the name field to sort all the tags by name. That's done. Now we did see some of these tags in operation in the previous part 12 video, and we'll explain them all as well as other tags as we move forward. Now let's talk about the new program structure we will be using. And to do that, let's save and then close the current program, and then open the completed program we used in the previous part 12 video to help explain things. Let's open the program blocks, and what we see are the main OB1, the startup OB100, followed by 4 functions. So why have we done things this way? Well, it's usually good practice to construct your code so that the PLC scans it in the following way. Firstly, we go through any startup routine, then the main body of the code, which is then followed by updating the outputs. The PLC then goes back and does the same again, although the startup code will be excluded from the following scan unless the PLC is stopped and then placed into run mode again, as it is used as purely an initialization block. Let's take a look at the flowchart and compare it to the finished program functions. The startup code box in the flowchart refers to the startup OB100 organizational block. The main logic code box includes the main OB1 organizational block as well as the load and remove functions. And lastly, the update outputs code box includes both the ladder outputs and the SCL output functions. Okay, let's close the finished project and open up project 12 again, which, as I mentioned earlier, I should have named 13, and then create the structure we have just seen. So let's open the TIA portal again and open part 12 video. Select the drop down on PLC 1 and then Program Blocks and double click the Add New Block. Now we'll select the organizational block, then Startup. We'll leave the language as SCL and then we'll select OK. Under Program Blocks, we can see Startup OB100 has now been created. Now before we add another function block, I'll just rename the function block 1 to A_load following the naming convention I used in the finished video. Obviously, you can use your own naming convention if you like. Now let's add another function for the remove code. Let's double click Add New Block. This time let's select Function and we'll need to select SCL. Okay, I'll name it B_remove and select OK. And as we can see under Program Blocks, we now have Function Block 2 and the screen opens ready to enter code. Oops, I created a ladder function. Actually, I will leave this for now and come back to it later so we can see what needs to be done to change it to SCL. Okay, two more functions to create, both for the outputs. So let's add both of those now. We'll name the first one C_ladder_outputs and we'll need ladder for the language and select OK. Now we'll add the final function block and we'll name this one D_SCL outputs. Select SCL as the language and select OK. Next, we will modify the existing ladder and SCL output logic to fit the new structure. Let's first take a look at the outputs in the ladder logic main OB1 and move them to the function block C_ladder_outputs. Let's scroll down to the bottom where the outputs are located. Now we could replace all the outputs in this network with internal bits. Then use the internal bits in the C_ladder_outputs function to operate the outputs. I would actually do this if the program was much bigger and more complicated. But in this case, I'm just going to make things simple by cutting the whole network code out and then pasting it into the C_ladder_outputs function. However, when it comes to the SCL outputs, we will replace the outputs in the SCL code with internal bits, as we need to make use of the same outputs again in the removal process. So let's move the ladder code by highlighting all the network code, then select Ctrl X to copy and delete. And let's open the outputs function and select Paste from the Edit menu or Ctrl V to paste the code. Great, now let's name the network to ladder outputs. Let's scroll down to make sure all the code is there, which it is. The next step is to edit the load function code and replace all the outputs with internal bits. So let's open the function and straight away in step 1 we can see reference to output stacker crane 1 left. This is one of the outputs we will replace with an internal bit. So what are the internal bits we will use to replace the outputs with? Well, to find out, let's have a look at the tag table and see what we've named them. So first of all, these are all the output tags, although the output tag output O_stacker crane tag position isn't really an output relay, and perhaps I shouldn't have named it as such. Anyway, I've decided to name the internal bits with the same names as the physical outputs, but omitting the prefix of O, as it again keeps things simple. Let's see these tag names in tag table 3. As you can see, the names stacker crane 1 right, left and lift are the names I've given to the tags. So now let's edit the S7-1200 function and replace all the output tags with the appropriate internal bits. Now it should be a simple case of just removing all the prefixes, so let's try that now. Oops, we have an error in the step 4 region, as this is a target position and that internal bit doesn't exist. So let's amend that by putting back the prefix of O. Great, that's done. Let's move on again. Oops, I've done it again to a target position. Let's change it back. And that looks like it's complete. Let's scroll up to make sure I've edited all the appropriate tags. That all looks okay. I'll just check there's nothing to the right. All good. The next thing we'll need to do is make use of the internal bits we've just added by using them to activate the appropriate outputs by entering them in the SCL outputs function. So let's do that now. So if I type if stacker crane 1 left is true, then output stacker crane left is equal to true. Now come down, else output stacker crane is equal to false. Then end if. So that takes care of the left output. Now we need to add the right and lift outputs. So rather than type the code in all again, I'll simply copy and paste what we've done and modify it for the other outputs. So let's highlight the code and copy it. Then paste the code in underneath. Now let's replace all references of left with right. Then do the same again for the lift. So copy what we just edited and paste it below and change all references of right to lift. Now I'll save what we've done so far. Okay, we're on the home stretch now. So let's change the SCL sequence numbering system, which is the way we stepped through the code in the previous videos when using the word to shift tag, which we changed the name of earlier to place pallet sequence number. So in the load function, let's make those changes now. Essentially, instead of shifting a value in a word, we are now going to simply add 1 to the value. And in so doing, the values match the step numbers we are on. It'll make more sense as we apply the changes, so let's do that now. In step 2, we will change place pallet sequence number from 4 to 3. Then change the name of the next region. Now let's change the if statement in step 3 to read place pallet number equal to 3. Then change place pallet sequence number from 8 to 4. So let's move down and do a similar edit to the remaining steps in the code. I'm sure this will be self-explanatory and will make the code easier to follow than it was previously. Okay, that's done, so I'll save the project. Then I'll just scroll back up and down again to check I have indeed made all the changes. Yes, that all looks fine. The place pallet sequence numbers all match the region step names, and we simply add 1 to the place pallet sequence numbers to move to the next steps in the process, which I hope we'll all agree makes more sense. The last change to the load function code we should make is to change the way we wrote the logic when we were checking for X and Z movements of the stacker crane. So we will change the if not variable statements to if variable statements, and this again should make more sense as we do it. So for example, here we have if not I underscore stacker crane move X, which we will replace with if input stacker crane move X equals false. We'll do the same for the Z movement. If not input stacker crane move Z is the same as if input stacker crane move Z equals false. Again, I think this makes a little more sense for people to understand, including myself. So where we see checks for move X and Z in the code, let's make the same changes. Right, that is all done. Well, almost. We just need to change the b_remove function to SCL instead of ladder. And the best way to do that is to delete the function and create it again. So let's do that. So that's done too, and we now are ready to add the first lines of the code to the program to allow us to remove pallets from the rack, which we will do in the next video. So until next time, hope you found this video informative. Thanks for watching. If you've enjoyed the video, please give it a thumbs up, and if you would like to learn more, then please click the subscribe button and the bell so you'll be informed as soon as a new video is uploaded. Please see the links in the description should you wish to get a free 30-day license of FactoryIO, and also check out my Patreon account. And I'll see you in the next video. Bye for now.